All the inequalities up to this point have had how many steps to solve them?
2. No, 2. 1.
One step, right? Either add a number to both sides, subtract a number, multiply by a number, or divide by a number, correct? Just took one step each time. What do we have to pay careful attention to whenever we're multiplying and dividing? Negatives. Anytime I multiply or divide both sides of an inequality by a negative, what did I have to do? Flip my inequality symbol. We'll still see some of those today. There's just going to be multiple steps involved in solving our inequalities. Everyone okay with that? But once again, though, it's very, very similar to solving equations. Trying to get the variable by itself. Once again, the only difference is we've got to flip that symbol if we multiply or divide both sides by a negative. So let's just jump in to some examples. Solve each inequality and graph each solution. Y over negative 6 plus 7 is less than 9. Y over negative 6 plus 7 is less than 9. Can someone tell me what my first step would be here? Yep. Yeah, subtract 7 from both sides. Just like with our equations, in order to get the variable by itself, I must first get this term containing the variable by itself first. So I've got to get rid of that 7. Inverse operations would be to subtract 7 from both sides. 9 minus 7? 2. After this step, does my inequality symbol flip or stay the same? Stays the same. I did not multiply or divide both sides by a negative, did I? Any questions on that? Okay. Is y now by itself? No. But the term containing y is by itself, so now I can focus on getting the variable by itself. So what would be my next step to get y by itself? Multiply by negative 6 on both sides. That way it'll cancel out on the left. Whatever I do to one side, I got to do to the other. So I've got y on the left. 2 times negative 6 gives me? Negative 12. And after this step, does my inequality symbol flip or stay the same?
Flips.
Why does it flip? Yeah, I multiply both sides of my inequality by a negative 6. So I've got to flip from less than to greater than. Is y now by itself? Yeah. Any confusion there? Like I said, just like solving equations, we still got to pay attention to multiplying and dividing by negatives. Questions on A before I graph it? Okay, let's graph it. What number is my circle going to be on? Negative 12. Open or close circle on negative 12? Open. Are we still okay with graphing? Am I shading to the left or to the right? To the right. I want all values that are greater than negative 12, so I'm shading to the right. There's my graph for letter A. Any questions on that? We still feel okay about solving inequalities? Okay. Can I erase and move to letter B?
Yes.
Just going to give myself enough room here. Letter B, 2v minus 4 is greater than or equal to 8. 2v minus 4 is greater than or equal to 8. Raise your hand if you can tell me my first step here. Yep.
Add 4 to both sides.
Yep. Add 4 to both sides. So I get 2v on the left. What's 8 plus 4? 12. And up to this point, does my symbol flip or stay? Stays the same. Only flip it if you multiply or divide both sides by a negative number. Any confusion on my first step? Okay. What's my next step here? Divide by 2 on both sides. Got to get v by itself. 12 divided by 2? 6. Symbol flip or stay? Stays the same. Is my variable by itself?
Yes.
Yes, it is. Questions how we got v is greater than or equal to 6. Hopefully we're kind of still getting the hang of it, catching on, right? Can I get a thumbs up, thumbs down, thumbs aside how we're feeling about it? Any questions if anyone has a thumbs to the side or thumbs down? Graph it real quick. Open or closed circle on 6? Closed. Shading which way?
Right.
To the right. Well, I want all values greater than or equal to 6. Questions on B? Can I move on?
Yeah.
Sweet. Okay. With equations, we talked about having a variable on both sides of the equation. So we're going to do the exact same thing with inequalities. Okay? When I was solving equations with the variable on both sides of the equation, what did I want to move to the same side first? Variables or the constants? Variables. Why did we do that?
Just to get on one side.
Just to get them on one side, but why did we do the variables first instead of the constants? What sometimes happened with our variables? They cancel each other out, right? And so if they cancel each other out, I got to look at the statement that's left over immediately after they cancel each other out. So that's why I got to do my variables first. Does that make sense?
Yeah.
So here, got a variable on both sides of the inequality. I want them on the same side. How would I do that?
2x minus 6x.
Yep, I can subtract 2x from both sides. Or if I wanted to, I could have subtracted 6x. It doesn't matter which one I subtract, as long as I'm getting them to the same side. Okay? What's 6x minus 2x? 4x minus 5. I've got 11 on the right. Does my symbol flip or stay after that step?
Stay.
Stays the same. Questions on that first step? Okay, I've got my variables to the same side now. What do I need to do with my constants? Yeah, I want them on the opposite side of the variable. So what do we say, Jake? Yeah, add 5 to both sides. So I'm left with 4x on the left. On the right, what's 11 plus 5? 16. Does my symbol flip or stay? Stays the same. I still have not divided or multiplied both sides by a negative number. Got my variables on the one side, my constants on the other. Now I can start trying to isolate the variable by itself. So how would I do that? Divide by 4 on both sides. I got x on the left. 16 divided by 4? 4 on the right. Symbol flip or stay? Stays. X is now by itself, so x is less than 4 is my solution to this inequality. Did I move too fast for anybody?
No.
Everyone understand each step we went through? So the steps are going to be just the same as our solving equations. If I can simplify one or both sides, I'm probably going to want to do that first. Get your variables to the same side, get your constants to the other side, isolate the variable. Same exact steps as solving equations. Okay? Did this tell us to graph it? No, so I'm not going to graph it. If it tells you to graph it, graph it. If it doesn't tell you to graph it, you don't have to graph it. Can I move on from example 2?
Yes.
Okay. All right, 2 more examples here. Letter A, solve 8b minus 3 is greater than 4 times 2b plus 3. Letter A. What would be my first step here on letter A? Distribute. Once again, like I said on the previous slide, simplify one or both sides if you're able to. Is the left side of my inequality able to be simplified at all? Combined like terms, distributive property, anything like that? No. No. But on the right, we said we could do distributive property. Four times 2b. 8b. 4 times 3. 12. We're still good with distributive property, I hope. You multiply through the set of parentheses. Can I simplify either side anymore? No, I've done all the simplifying I can do on each side of the inequality. Everyone agree with that?
Yeah.
What would be next? What do I need to do next? Yeah, get my variables to the same side. How would I do that? Subtract 8b from both sides. What happens when I do that? Variables canceled out. This is what we just talked about earlier on the previous slide. I need to move my variables first before my constants, just in case they cancel each other out, so I can look at the statement that's left over. So what do I have left on the left-hand side? Negative 3. What do I have on the right-hand side? Positive 12. With this step, do I need to keep my inequality symbol the same or flip it?
Same.
Keep it the same. So I have the statement, negative 3 is greater than 12. Is that true or false? False. Negative 3 is not greater than 12. So what would my answer be here? No solution. There we go. Questions on letter A? Same exact concept with solving equations. If your variables cancel each other out on both sides, I get a false statement, no solution. Okay? Questions on A? Excuse me. Letter B. 2 times 5w minus 1 is less than or equal to 7 plus 10w. What do I need to do here? Distribute on the left. Can simplify the left-hand side by using distributive property. 2 times 5w. 10w. 2 times negative 1. Negative 2. Can I do any simplifying on the right-hand side? No, it just stays as 7 plus 10w for right now. Questions there? Questions so far? Can I do any more simplifying on either side?
No.
No? So raise your hand if you can tell me what to do next.
You get the variables from inside.
Yeah, how do I do that?
10 minus 10.
Yep.
And then that would cancel out.
Yep, I got to get the variables to the same side. So I subtract 10w from both sides. But, like we said, our variables cancel each other out. What's left on the left? Negative 2. What's left on the right? 7. With this step, does my inequality symbol flip or stay the same? Stays the same. So, variables cancel each other out. I've got to look at the remaining statement that it's telling me. Negative 2 is less than or equal to 7. Is that true or false? It is true. With less than or equal to, it's only got to meet one of these conditions for it to be true. So it must be either less than or it must be equal to. Does negative 2 fit either one of those conditions compared to 7?
Yes.
Yeah, it fits the less than portion, so it is a true statement. Does that make sense? Negative 2 is less than or equal to 7. So if I get a true statement, what do you think I need to put? Huh? I like your thinking here. If we were solving an equation, we would put infinitely many solutions. Infinitely many solutions. But if I get a regular solution for an inequality, how many solutions do I have with that? If I get like x is greater than 7, how many numbers are greater than 7? An infinite number. So I need to be a little more specific here. I'm going to say all real numbers. Every single real number will make this inequality true. We do have a symbol for that. It's a capital R with 2 stems on it. So I draw 2 stems, draw my R. All real numbers. Does that make sense why we're putting this and not IMS? Because with a regular solution for an inequality, we already have infinitely many solutions. So we want to be a little more specific here that it's all real numbers. Okay? Any questions on B? We okay with multi-step inequalities so far?
Yeah.
Simplify one or both sides if you're able to. Get the variable on the same side. Get the constants on the other side. Isolate the variable. If it tells you to check your solution, check your solution. If it tells you to graph your solution, graph it. We actually can graph letter B, all real numbers. Do you think we're able to graph letter A, no solution? No. We wouldn't do anything on our graph, we just leave it blank. If we wanted to graph all real numbers though, if it told you to graph this, create a number line, put any numbers you want on it, and then you're shading the whole graph. Because every single number on a number line is a solution to this inequality. It might tell you to graph those. So that's how you graph it. You just shade your whole graph that they give you. Or you'd have to draw your own graph. Like I said, put any numbers you want on it, because all real numbers are solutions here. Okay? No solution, leave your graph blank. Questions on example 3, A or B? Can I move on?
Yep.
I just want to show this to you real quick. You might see this in future math classes, set builder notation. An example of set builder notation is this right here. And this is how we would read it right here. These little braces denote a set. So this would be the set of all real numbers x. This little bar right here means such that x is less than or equal to 5. It's just another way to represent the solution set of an inequality. Okay? So just be aware of that. I'm not going to really ask you to write it like that at all, but just be aware of that for future math classes. Okay? Here you go. Page 83, numbers 4 through 30, evens. There's your assignment. This will be due Monday, '26th on Canvas. You've got a decent amount of time left in class. You got like 25 minutes left. You've got about 14 problems, I believe. So you should be able to knock out quite a bit of these. Okay? Get this written down. Get the correct heading on your paper. Name, date, period, assignment in the upper right-hand corner. Are there any questions about the notes before I end the recording?